Let's start by looking at the structure of this intraseasonal variability. ISV is used as an acronym for intraseasonal variability. So this was the data that was used by Madden-Julian in terms of determining the spectra of surface pressure. All these bands shown here are in the 40 to 50 day period, which is the intraseasonal time scale. So we keep switching between 20 to 60 days, sometimes 20 to 100 days, sometimes 40 to 50 days, depends on the data that's available. On the vertical axis and in red colors are these variance spectra of surface pressure in terms of HPA per meter squared, or whatever the appropriate unit is. And you can see that everywhere along the tropics there is this 40 to 50 day band, and there is energy in those bands at various levels, except over Africa. African stations have much more of a 10 to 20 day band variability, more like the 2 to 10 day variability in the easterly waves, and then 10 to 20 days or quasi-biweekly variance. So that is not fully explained, but nonetheless you can see that the variance in the 40 to 50 days is quite dominant across the stations that were used in this study. This is showing now the variance spectra of surface pressure computed by Madden and Julian for tropical locations throughout the tropics, with the propagation shown in these big gray arrows with slower meridional propagations as well. So it's very tempting to think with those schematics we always see about the convection propagating eastward, that maybe this is some kind of a longitudinal vertical two-dimensional structure, but actually it has quite a bit of meridional structure as well. These are the phase angles, mean phase angles with respect to the Canton Island, and when it's dashed lines, Canton is lagging, and when they are solid lines, then Canton time series is leading. So you can see there is propagation out and towards the meridional direction, and these solid circles with these numbers are coherences in the 30 to 50 day band that are significant compared to the background coherence at 95% level. Essentially that means that the time series of a quantity like the surface pressure have covariance or over time. They stay together for significant amounts of time based on how strong the coherence is. For example, here 0.88 down to 0.2 and so on. Okay, so you can see that this signal kind of dies away as you reach here, and there are various ideas that, if you remember the equatorial upwelling and the sea surface temperatures being colder, that the MJO related convection dies off, so you don't have convection over these cold SSTs which are too cold for driving atmospheric instability and convection. But there is some evidence that the atmospheric signal in terms of vorticity or velocities continues across and comes back over to the Indian Ocean. So there are MJOs that are considered circumnavigating, and there are MJOs that tend to originate here and then propagate eastward. There are also debates about whether the circumnavigating MJOs come across and then they are reignited somehow over these processes, and we will see that even the genesis over here of the MJOs is argued to depend on extratropical perturbations coming in from the southern hemisphere. So we have learned about how the westerly duct and the upper tropospheric trough facilitate the communication from the extratropics to the tropics, and also here, but similar communication here seems to be associated with genesis of MJOs. Okay, as I said, this is all kind of still open questions, and a lot of it is diagnostics based on data. More recently now we have a lot more data from satellites, from ships, and from reanalysis, so the blending of available observations with models to create dynamically interpolated data products. They are not really data, but people often call them data. So as we saw before, this is from chapter 8. If we look at convection being a peak at day 0, then we can look at days before and days after, so composite days going from few pentads before and few pentads after. And we had talked about fast moving surface pressure signals. So A prime here is moving much faster than, and here as well, than the convective signal as seen in the OLR anomaly, which is in this magenta color negative, and this is positive. So high pressure associated with positive OLR anomaly or dry phase, negative pressure, surface pressure anomalies associated with the slow-moving convective phases seen as negative OLR anomalies. And you can see again that the signal is not so coherent on Africa, so more like genesis is happening over the eastern Indian Ocean. This is looking at mean sea level pressure and 200 hectopascal geopotential, basically indicating that the MJO related convection is occupying the entire troposphere, and this is again geopotential showing strong signals associated with the perturbation of the convection, associated vertical stability change, and so on and so forth. For the differences in speeds, we talked about convective dissipation, and we talked about the turbulence of the convection creating friction and mixing and dissipation. We talked about ocean-atmosphere coupling, and we talked about changes in the vertical gradient driven by the convection itself, and so on. So that is still valid in terms of talking about the phase speeds of the MJO convection and dry phases. So this again is an indication that there are mass intrusions from higher latitudes. So if you look at the equator, the surface pressure don't add up to 0 in terms of anomalies. So there is mass exchange on large meridional scales, which would create angular momentum imbalances, which would appear in the data that Madden-Julian actually show that there is an angular momentum signature associated with these large-scale exchanges of tropical extratropical masses on these MJO timescales. Okay, but that latitudinal structure again shows you that it's not a two-dimensional equatorial vertical kind of process, but has a significant meridional scale as well. Okay, so we'll come back to other details as we go on, but I hope it's clear what we are looking at. We are not specifically linking to all the processes we looked at before in terms of waves, basic state, modulation of the waves, and so on and so forth, but all those processes do occur at these timescales and are part of the MJO evolution and propagation.